Hi, in this video we're going to look at a very key and fundamental concept to drone flights, which is GSD. Now a lot of people think they understand GSD, but the thing is that GSD is more diverse and more complex and more useful than most people imagine. We'll have a look in this video. Hey everyone, I'm Varun, the founder and CEO at Hammer Missions, and in this video I want to talk about GSD, also known as ground sampling distance. So a lot of people think they understand GSD because intuitively, once you understand what ground sampling distance is, it seems clear and you can basically start using it in your drone flights. But GSD is so much more useful once you fully appreciate what it's built for and what it can be used for. So let's start with understanding what GSD actually means. So the definitions first. Ground sampling distance, as the name implies, is essentially the amount of ground or the amount of surface area covered by the camera on your drone in the flight. So if you imagine that every single image that a drone takes is built up a little bit of all these different pixels, and each pixel essentially represents a square on the ground, how big or small that square is essentially what the ground sampling distance denotes. You're essentially sampling the ground using the camera on your drone and therefore the ground sampling distance. Now, what a lot of people don't understand is that the ground sampling distance doesn't have to apply to just ground. It can apply to any surface. So if you're capturing the data vertically, it could be essentially the facade that it's being mapped in the camera of the drone that represents the ground sampling distance. Albeit it should really be called facade sampling distance or surface sampling distance or something like that. So essentially, ground sampling distance does not have to include the ground, it has to include what is being mapped. And one of the key concepts that we see attached to this is essentially the overlap between two images on the roof for a roof inspection job. What happens is that a lot of people think that the ground sampling distance is actually with respect to the ground, but most of the times the software is calculating this with respect to the roof or with respect to the surface that's being seen by the drone image. So the key concept here is that ground sampling distance does not always apply to the ground. It applies to any surface that can be mapped by the drone. And once again, it's actually the footprint of every pixel in the drone's image on the ground, which I'm showing in the illustrations here. Right, so now that we understand what ground sampling distance is, or surface sampling distance, whatever you want to call it, let's try to understand what does it affect and why does it matter. So first of all, the ground sampling distance affects the resolution of the data. Now, this is a bit like when you have an HD TV versus a 4K TV versus a 720p TV or video stream. You've got different resolutions, which means that you can see different amount of detail in the end result of the end deliverable from your drone outputs. Counterintuitively, a low GSD means higher resolution data. Now, why is that? It's because every single pixel in your drone's camera will be representing a smaller footprint on the ground if the GSD is low, and would be representing a higher footprint on the ground if the GSD is high. And if the footprint on the ground is lower, it means that you're capturing a lot more detail, you're capturing a lot more pixels to cover the same area, and therefore the resolution of the data overall is going to be a lot higher. So that's one counterintuitive concept, that lower the GSD, better the resolution of the data. Now, one of the things that we always see is that, given that's the fact, should you always try to reduce or lower the GSD possible in every single drone flight? And the answer is not really. I think with every drone flight, what you need to do is strike a good balance between data quality, safety, and efficiency. And flying close to the ground means that you have a low GSD and you have a high resolution output, but it might mean that your flight takes really long. It could also mean that you're unsafe because you're now very close to obstructions and you're probably not compliant when it comes to staying away from objects and people not under your control. So really important to find a balance between the flight altitude, the GSD, and the camera parameters. And this is essentially another key concept, is that GSD depends on things like your flight altitude, depends on your camera, and finding a good balance between those parameters is imperative to a successful drone operation. So second most fundamental concept here is low GSD means high quality data or high resolution data, but high resolution does not always mean high quality. Sometimes you need to be able to make a trade-off between safety, quality, and efficiency. Right, let's move to the next concept. So the next concept is what GSD can affect and why does it matter? So GSD can affect things like data accuracy. Now, if you're doing a drone flight for a mapping or a modeling purpose, you might be interested in how accurate your map or model is in the end. And accuracy comes in different shapes or forms. There are two different types of accuracy. One of them is relative accuracy and the other one is absolute accuracy. Now, we talk about accuracy of drone data in a separate video, so I'm going to link that here and feel free to check that out after this video. But essentially, measurement accuracy or georeferencing accuracy are two different names given to relative accuracy and absolute accuracy. And the simple fact of the matter is that if you want to take measurements from your maps and models after you process the data, then those measurements can be very accurate, but it all depends on the GSD you use to capture that data. So we have done certain experiments in the past where we have captured stockpiles, and we know that the accuracy of the stockpile is very much dependent on the GSD used to capture those stockpiles, and therefore GSD is really important with respect to a certain application, and you need to always take that into account. The same holds true for georeferencing accuracy, where you want to make sure that your map or model is very much aligned with the ground truth, with other maps and models, and you're able to essentially place the data in the right place or peg it on the map exactly the same place every single time as you capture the data. And for those types of georeferencing accuracy, it's important that your GSD is somewhere between 2x the required amount of relative accuracy. So again, we talk more about data accuracy in a separate video, but the key concept here is that GSD can affect both georeference accuracy and measurement accuracy, and it's important to understand the constraints around what you can and cannot do with GSD with respect to those applications. Right, moving on. The next thing that GSD really affects is motion blur. So motion blur is something that happens in almost every drone flight, and it's essentially, it can be described as the amount of ground smear on the camera screen as your drone flies. And intuitively, it can be easy to understand. I mean, you're flying a drone, it's a flying sensor, and it's going to pick up some motion as it captures those stills. And so therefore, it's important to understand that maybe you're not able to minimize motion blur. Maybe you're not able to completely eliminate motion blur, but you may be able to minimize it. But what's really important with motion blur is that you need to make sure that your motion blur is not 2x your ground sampling distance or more, because if that's the case, then whatever you're processing, your map or model, is not going to have the same level of quality at the end, and you're going to experience certain objects not looking as good as you expected. So again, GSD and motion blur are correlated. It really depends and matters whether or not you have used the right GSD given the right job. Right, okay, and finally, another concept for GSD is mapping versus inspection. So GSD can have different influences depending on the end application. So if you're doing mapping, and as I mentioned before, you have things like measurements that you might want to take from the map, or you might want to do some form of modeling, and you want to understand where the model is in 3D space with respect to the real world. For all of those things, it's really important that GSD is aligned with your data accuracy. But then there are other use cases like inspection, where you're trying to understand the condition of a built object, the condition of a built asset. For those use cases, the GSD has actually a different implication. And that implication is that the GSD essentially dictates whether or not you'll be able to see a crack or a defect in the output images. So if you think about it, if you have a crack on a wind turbine or a facade or a solar panel or any of your favorite assets out there in the world, you need to think about how big that crack will be and whether or not it's going to show up in the data given the GSD you're capturing. So you can think about the crack as a function of the GSD, and you can actually use it to back calculate how big or small would the crack look as a fraction of the total image. So what I'm going to do here is I'm going to throw in some parameters which show you essentially the image size, the GSD, and what every pixel on a particular wind turbine or asset might look like, and how big or small it might look depending on the GSD of your capture. So key concept here is that when you're looking at inspection use cases, the GSD has got to do more with how big or small objects look in the final images, as opposed to the accuracy of the data, because you're not really doing the mapping side of things. So once again, GSD, very fundamental concept, but has different implications depending on your end result or your end outputs. So those were some of the things that I covered in this video, which are all centric to GSD. And we think that the GSD concept can actually be applied to many more things. It can also be applied to accuracy of stockpile volumes. It can be applied to understanding whether or not you are flying at the right altitude, at the right distance, whether you have the right camera or not. And all of these different parameters in a drone flight need to be fine-tuned, and they need to be set correctly depending on the mission you're flying. And I think as a drone professional, it's really important to understand these concepts so that we can move the entire industry towards collecting high quality data and planning flights with all of these right parameters in. Right, hopefully this video was interesting. If it was, do give us a like. If you think that other team members or people in your in-house drone program might benefit from watching it, please do share it with them. Thanks so much for watching. As always, we'll see you in the next video for Knowledge Hub.